Hello, this lesson is going to be on the surface area and volume of solids, in particular of cylinders. Cylinder is one three-dimensional shape which you can see pictured here. It has a circular base down here and a second base up here, and it also has a lateral curved surface that goes around it as well. And we can see that over here when we look at its net. This is a picture of a cone, a cylinder, in essence unwrapped. So here's this top lid kind of popped up here. The bottom part is popped down, and then it's almost as if we took scissors and cut here. Imagine cutting like a toilet paper roll. If you cut it and open it out, it's not going to want to lay flat, but it will be in the shape of a rectangle actually. And in this case, we also have some measurements involved. So this is the height of the cylinder here. So if we were to unwrap it, I know this is a slightly different size here, but this would be the height, this dimension here. And then we have a radius. So a radius would be also here, or here, or here. The radius is constant for a circle. We also have the circumference of the circle all the way around here, and that is actually what this length is here. This is the circumference. You can take a moment to kind of picture that, or actually cut a paper towel roll or a toilet paper roll and see how that happens. So this circumference is right here, and it's actually the same length as this. And in fact, it has to be, when you think about it, this length here has to be the same as this length here, because if you were to wrap it back up again, this is exactly kind of one-to-one correspondence with the circumference. We know the formula for the circumference of a circle is 2 pi r, or sometimes you write it as pi d, where d is the diameter. And here's our height, here's our radius. Okay, so we're good to go. We're going to talk about two things, both the volume and the surface area of a cylinder. And the volume is 3 dimensions, so our units are going to be cubed for volume. And pretty much, as for many shapes, anything that's a prism type shape, the volume is always just the area of the base times the height. Pretty straightforward. In this case, the base happens to be a circle, and I'm going to go ahead and write that out. Area of base times height. And in this case, again, the base is a circle, so the area of a circle is pi r squared, and height is h. I can do little dots there, I don't have to. So there's our formula for a cylinder. And you can kind of imagine it as the area of this circle, and kind of imagine the circle being like stretched up through space, forming the cylinder. That's kind of one way to think of it. It's stretched up throughout the whole height. So it's the area of the circle stretched all the way up through the height, and that gives us the volume of the entire shape. The second formula we're going to use is for surface area. This one's a little bit funkier to think about, but we can do it. We're going to use the net to help us. So when we're talking about the surface area, that's a two-dimensional thing. And so our units will be squared. We're going to talk about the area of all three of these components here. So these two are just bases. These are two bases. So the surface area is going to be equal to 2 bases, the area of 2 bases, plus this rectangle here, this curved surface. Sometimes we call it the lateral surface because it's on the side. It's kind of the side of the cylinder. So the base again is a circle, and the area of a circle is pi r squared, and we have 2 bases, one here and one here, so we have 2. And also, the area of the curved surface is height times length, right? So we have h times the length is 2 pi r. So there we go. Sometimes we'll see the formula written a little bit differently because we've got a 2 and a pi and an r and an r here, and we have a 2 and a pi and an r and an h here. So if we were to factor out a 2 and a pi and a r from each one, we'd be left with h, well, we'd be left with r over here and h over here. If that doesn't make sense, that's all right, but if you were to go backwards to make sure we factored it correctly and distribute the 2 pi r to this and to this, you'd end up with what we started with. So I'll leave it here, but I just wanted to mention the other formula as well. That's for surface area. So let's talk about how to actually use these in some actual problems. I'm going to take you through a series of steps. If you'd like, you can pause the video and read through these steps yourself, but otherwise I'm going to walk you through what it looks like in an actual problem. I want to make one note that since we're using circles and we have pi involved, pi is an irrational number and we write it with this symbol here. And if we just leave our answer with pi written like that, then the answer will be exact. However, it's not always easy to kind of quantify or picture when we leave it like that. So we often do approximate pi as being approximately equal to 3.14. It's actually 3.14159, and I forget what comes after that, but a long string of digits that does not end ever. So if we were to approximate it to just 2 decimal places here, then we're approximating the answer. I want to write that. If we leave it as pi, then that's the exact answer. But we often approximate the answer, and we just use the wavy equal sign. All right, here we go with an example. It says, find the volume of a cylinder with a diameter of 3 inches and a height of 5 inches. Use 3.14 for pi and round your answer to the nearest tenth. Okay, so here's a picture they already drew for us. I see that the height is 5 inches, the diameter is 3 inches, great. And so I'm going to walk us through these steps here. Step 1 is to identify the shape. So I'm actually going to write that down. I can see that it's a cylinder. It told me that it was a cylinder. Also, write any other information that might be helpful, like if the diameter is given, write what the radius is too. So we're going to do that here. The measurements that are being given is that the height is 5 inches and that the diameter is 3 inches, but we're also going to write right away, because our formulas all have r instead of d. We're not going to get tripped up. We're going to go ahead and cut d in half and say that the radius is 1.5 inches. So we now are going to clearly identify what's being asked for. It says find the volume. So what we need to find is volume. Volume equals what? That's the question. Now we're going to write down the formula that we need. The formula that we're going to use needs to involve the volume, and it needs to be the formula for the volume of a cylinder, not the volume of a different shape. And so the formula that we're going to use is volume equals base times height, or in this case for a cylinder, it's pi r squared times height, because this is a circular base. All right, then we're going to calculate by plugging in. So we have volume, which we don't know, we'll leave it as a v, is equal to pi, that's 3.14, times r squared, r is 1.5. Now notice my decimal places and my multiplication symbol are kind of similar looking, so I'm going to try to be careful. Times h, and h is 5 inches. I'm going to leave off my units here. I don't know. I'll include them. It's a little bit better. So once I do all this multiplication, it's nice that the variable I'm looking for, or the unknown, is already isolated on the left-hand side. That makes it nice and convenient. So the volume is equal to, we've got inches squared times 1 more inches, so my units, my final answer, are going to be inches cubed. And then we're just going to, we're going to have permission for this to just go ahead and use our calculator. 3.14 times 1.5 times 1.5 times 5. And the answer is 35 point, now it says to give my answer to the nearest tenth, so it's going to be 35.3 inches cubed. Because there's 2/100ths, so that doesn't round up the 10. The 10 stays as 3/10 there. All right, so there's my final answer with the units right there. And we are done. Let's look at another example of the volume of a cylinder where the unknown isn't already isolated on the left-hand side. You can pause and read if you like. But I'll read here. It says, at a grocery store, a package of breadsticks is shaped like a cylinder. Here it is. So the shape is a cylinder. The volume of the cylindrical package is 36.9 cubic inches. So I'm going to go ahead and write that right here. They already gave us that the volume is 36.9 cubic inches. We write it like that, inches cubed. The radius is 1.4 inches, so I'll go ahead and write that down. Now I could write on the side that the diameter is 2.8 inches, but that's probably not going to be necessary. They gave us the radius, and that's what our formulas use. What is the height of the cylindrical package? So what we need to find is h. We don't know what h is. Okay? Now, what formula should we use? Well, we're given volume, so we're going to use the volume formula for a cylinder, which is volumes equals base times height. So for a cylinder, it's pi r squared times height. Let's go ahead and plug in 3.14 for pi. We're going to plug in 1.4, 1 4/10 for the radius squared. And for the height, we're just going to leave that as h. But on the left-hand side for the volume, what we're going to plug in is the 36.9. So now we have 36.9, and on the right I'm going to go ahead and simplify all these things as a coefficient of h. We're going to do 3.14 times 1.4 times 1.4, and we get, I'm going to leave a lot of decimal places here, this number here. So finally, since we're wanting to find h, it asks us what is the height. We need to isolate h. Right now h is being multiplied by a number, so to undo that, we're going to divide by that same number. But if we divide by that number on the right, we also have to divide by that number on the left in order to keep our equation balanced. So on the right, we're just going to end up getting, this reduces to 1h, or just h. And on the left, 36.9 divided by that number there is equal to 5.995, and it says round to the nearest inch. So actually this is approximately equal to, because we plugged in an approximation for pi. So h is approximately equal to 6 inches. Now let me make sure, is that correct? Should it be inches squared or inches cubed? We're talking about height. So height is a one-dimension thing, so it is just inches. If I wanted, I could go ahead and plug in a radius of 1.4 and a height of 6 into the volume formula and make sure that I do in fact get this volume. And if you take the time to do that, you'll find that you do. Alright, we're going to do 2 more problems. Both of these we'll find out have to do with surface area. A cylinder has a height of 15 centimeters, so here we go, we're going to note that down. Now notice I didn't give you all this nice little kind of scaffolding here, but we're still going to do that same work. We're still going to write things down. We have a cylinder. The height is 15 centimeters. A radius is 4 centimeters. And the question is, what is the surface area of the cylinder to the nearest tenth? So surface area equals what? That's what we're looking for. It also tells us how to approximate pi. Alright, well we know a formula for surface area. The surface area of a cylinder is equal to its 2 bases plus its curved surface. And I'm gonna write this out each time because it's not about memorizing but truly understanding what we're doing. So I'm gonna keep writing it out. So that means it's equal to 2 circles, which is pi r squared, and it's equal to the circumference, which is 2 pi r, times the height. So there's our formula for surface area. Let's plug our numbers in. We've got 2 times pi times radius is 4, squared is 16. I'm just going to square it right now. Plus 2 times pi times 4 times height, which is 15. So I'm going to go ahead and plug all of that into my calculator, and we end up getting, let's see, I'm going to clear this out. 2 times 3.14 times 16. Times 3.14 times 4 times 15. And when we sum those two together, we get, it says round to the nearest tenth, so we end up getting, oh, and these are approximations because we plugged pi in. We end up getting 477.3. I'm going to round that up. Our units are centimeters, and this is surface area, so it should be centimeters squared for area. So there we go. Last question for this lesson. We're going to find the radius given the surface area and the height. Okay. So find the radius of a cylinder. So radius is what? It's a cylinder, okay? If the area of its curved surface is 12 pi, I'm going to write that up here, square meters. So that would be meters squared is our units. And its height is 2.5 meters. Curved surface, 12 pi meters squared. So they don't tell us the whole surface area, they just tell us the curved surface. And of course we know that the curved surface is equal to the height times the circumference, which is 2 pi r. So that means that 12 pi is equal to the height of 2.5 times 2 times pi times r, and we don't know what r is. Actually, in this case, since there's a pi here in this form, I'm just going to leave this as pi, and we'll see what we get. Let's simplify a little on the right. 2.5 times 2 is 5. And we have a pi, and we have r. All right. So we're going to divide both sides in order to solve for r. We're going to divide both sides by 5 pi. Our pi's are going to cancel out. These pi's will cancel out and the 5's will cancel out perfect. And we get r is equal to 12/5. And we can simplify 12/5. 12/5 is 2 and 2/5. And 2/5, which is the same as 2 and 4/10, which is the same as 2.4. So if we wanted to write it as a decimal, we would write 2.4. Our units are meters, and that's what the radius is. Now, is meters correct? Should it be meters squared or meters cubed? It's a radius, which is a one-dimensional length, so it is just meters, so we're good to go. So hopefully that helps with showing you a format very clearly for how you can show your work and make sure you're solving the problems correctly. Have fun.